Hi, so this video here is dedicated to some more differentiation being used with motion problems. So what you need to know is the velocity of an object will be increasing when its acceleration is positive, and the velocity will be decreasing when the acceleration is negative. That's pretty simple. But you often have questions when they're asking you about the speed. So the particle will be speeding up, or the speed will be increasing, when the velocity and acceleration have the same sign. So they're either both positive or both negative, doesn't matter what. So think about how this is. If the acceleration is a vector going this way and the velocity is a vector going that way, this will be a situation when you are speeding up. Think about a situation. You're standing at a traffic light and the light turns green. What do? You hit the gas pedal, and when you hit the gas pedal you're going to start moving forward, which means your velocity is positive and your acceleration is what's causing your car to move faster and faster. So your acceleration is going to be positive as well, and they're both positive, and you are speeding up because you're going faster and faster. Okay? The same thing will work if you're going backwards. If you decide to go in reverse, if you stop and then decide to shift in reverse, and because you just realized you missed something and you just go back like 20 feet, then the same thing will happen. So this will be speeding up. The speed will be decreasing, or the particle will be slowing down, when the acceleration velocity have opposite signs. So let's say you have positive velocity but negative acceleration. The best example I can give you here is, so you're driving on the road and all of a sudden you see up in the distance that the light is turning red, and you're getting close to it, so you're gonna start slowing down. You're gonna press brake, and when you're pressing brake, what happens is you're still continuing to move forward, which means your velocity is positive, but the acceleration is what's causing your car to slow down. That's the brakes being applied in this case, and the acceleration vector is going to be directed in the opposite direction, so this is going to be slowing down. Okay, so that's one thing that's important to understand. So these are two different questions when asking about the velocity increasing versus particles speeding up. Alright, so let's take a look at this problem. The velocity function is moving along the horizontal line given by this function. At what time, so please note we have a velocity function here, and at what time does it change direction? So the particle is going to change direction, or any object is going to change direction when the velocity becomes 0 and the velocity is going to change the sign. So the first thing we need to do for these types of problems is we need to set the velocity equal to 0. So t squared minus 6t plus 5 equals 0. That's something that I can factor. So it's going to be t minus 5 times t minus 1 equals 0. It's going to give us 2 points. But we need to be careful because we don't know if the particle actually changes direction. These are just the points where the particle is going to stop. Now, if you're driving on the road and you came to stop at the traffic light or a stop sign, and you're going to continue moving in the same direction probably. And does that mean you change direction? No. So we need to check for sign changes here. So what we're going to do is we're going to make a sign chart, which is going to be labeled v of t, and we're going to analyze the signs here. So what happens here with signs is from 0 to 1, you're going to have a positive positive velocity. Here you're going to have negative velocity, and here you're going to have positive velocity again. So, since we see the sign change here at both 1 and 5, that means the particle is going to change direction. So we're going to write changes direction. at t equals 1 and 5 because v of t changes sign at those points. Okay, it doesn't matter from what to what, it just changes sign, which means the direction is going to change. So here, for example, you are moving forward, and you switch to moving backward, and now you're moving forward again. When is the velocity of the particle increasing? Well, the velocity of the particle is going to be increasing when the acceleration is positive. So we need to find the acceleration. So the acceleration function here will be the derivative of velocity, which is going to be 2t minus 6. Right? You set this equal to 0, you have t equals 3. So what we need to do is make a sign chart again. Put 3 here. This is the acceleration. And check the signs. So the signs here will be, you will have negative sign here and positive sign here. Right? So we're looking for the velocity to be increasing, and that's going to happen when the velocity, so we want the acceleration to be positive from 3 to 7. So the velocity is increasing on the interval from 3 to 7. Remember, we're only going up to 7 because the acceleration is positive there. Okay? And now that's just to show you the big difference here. The particle is going to be slowing down when the velocity and acceleration are going to have different signs. One of the best suggestions I can make for you here to make it easier to analyze. So we're going to graph our velocity function. Well, make the sign chart, I should say. And right underneath that or above that, you make a sign chart for the acceleration. Okay, and we want to put our signs here. So we have I already know this, plus, minus, plus, and this is minus, plus. So what we're looking for, since the particle is slowing down, we're looking for different signs of the acceleration and velocity. So where is it? Let's see. So on the interval from 0 to 1, the velocity is positive, the acceleration is negative. So that's one point. So what we're going to say is the slowing down on, first of all, we're going to have an interval from 0 to 1. Then what happens? Between 1 and 3, they're both negative, so this is where the particle is going to be speeding up. Then from 3 to 5, you have negative velocity, positive acceleration, opposite signs, so that works too. And then from 5 to 7, they're both positive. So only from 0 to 1 and 3 to 5, we need to justify it because v of t and a of t have opposite signs there. Okay, so that's the big difference, because speeding up is not the same as velocity increasing. Okay, this is where you compare the signs of velocity and acceleration, and if they're both the same, both positive or both negative, the particle is going to be speeding up. But when they're both when they have opposite signs, it's going to be slowing down. All right. Now I do have some more. We're not quite done here because I do have something with the graph. So what we have here is the graph of the velocity of the function that looks like this. So it consists of there's a part of a parabola here, a line, a bit of a parabola, and more lines. So this is on the interval from 0 to 12. and this is the particle moving along the y-axis. So approximate the acceleration. So since this is the velocity, the acceleration can be approximated as the secant line here, since we don't have the exact equation here. So to approximate the acceleration at 3.5, we're going to use 0.2 and 0.3 and 4, and A at 3.5 can be approximately evaluated as the difference quotient. So we can use V of 4 minus V of 3 divided by 4 minus 3, right? And that's going to be V of 4, according to the graph, is 3. V of 3 is 0 divided by 1, so we can say it's approximately 3. For what values of the of t is the particle moving up? The particle is going to be moving up when the velocity is going to be positive, right? So where does that happen? Well, now remember, we're looking at the graph. So it's going to happen here, when the velocity is positive between 0 and 1. It's going to happen again from 3 to 6, then again from 6 to 10, and that's it. So we have 0 to 1. We also have 3 to 6, and we also have 6 to 10, because V of t is positive there. And at what values of t does the particle change direction? So remember, first of all, we need to have velocity equals 0, and that's 1, 2, 3, 4 points. But not all of them, not at all of them, the particle is going to change direction. If you look at this point 6, the particle had positive velocity to the left and positive velocity to the right. You don't change direction here. That's like you coming to a stop sign, and then, after checking everything, proceeding to move in the same direction. But anywhere where the velocity is going to change the sign is where the particle is going to change direction. So it's going to happen at 1, at 3, and at 10. So at t equals 1, 3, and 10, because we do need to justify this. V of t does what? It changes sign, right? Okay, so that's how it works. I do have a couple more questions for the same graph, just to help you understand this better. So same graph. So continuing this, I got part D. For what values is the velocity decreasing? The velocity will be decreasing when the acceleration is negative, right? So we want A of t to be negative. So that's when the slope of the tangent line is going to be negative. That's going to happen where? So it's going to happen here, because the slope of the tangent line is going to be negative. So it's from 0 to 2. Then again it happens from 4 to 6. Then again it's going to happen from 8 to 10. And not over here, because actually, yeah, because here the slope of the tangent line is going to be 0. Because A of t is less than 0 there. Okay. And this is where it gets, this is probably the pinnacle of all of it. Where is the particle speeding up? So we do need to have matching signs for acceleration and velocity. So let's see. What do we have here? Here we have positive velocity but negative acceleration. So that's slowing down. From 1 to 2, the particle is going to have negative velocity and negative acceleration. So that's one of those points, right? Below the x-axis, and the tangent line is going to have negative slope. So from 1 to 2. then what's happening with the particle here? It has still negative velocity but positive acceleration, so that doesn't work. But from 3 to 4, the particle has positive velocity and positive acceleration, so that works. What happens at 4? The velocity is still positive, but the acceleration is negative, negative tangent line, so that doesn't work. Then we're going to go from 6 to 8, right? From 6 to 8, positive velocity, and the tangent line is positive, so positive acceleration. So 6 to 8, and then we're going to have negative positive velocity but negative acceleration here. But over here from 10 to 11 we have negative velocity and negative acceleration. So we're going to have 10 to 11. Okay, we do need to justify it because v of t and a of t have opposite signs there. Okay, so that's how it's done. I hope this helps.